All right, guys. Let me see. Well, let me see. 1 second. I am sitting with only one screen today, so I'll not see. I can see everything. Okay, I think all our guests here thought. So let's start the presentation.
Okay,
Let's
sounds
go to
great.
next step. Okay, good. So first of all, let me introduce Bob. For those of you who have not met Bob yet, and since I've seen the registration file, and there's a lot of you that I've never seen before, so let me take this time. Bob is an expert, a super expert of IEX, and works for a company called Source ICX, and which is a distributor of GMI. But he's also a CompEX instructor and assessor for the ICEX CompEC scheme. He's an inspector, so he does a lot of inspection on plants, and is a member of the US ULSTP committee for the adaptation of the new standard. So he knows a lot about the 60079 standard and what's upcoming. On my end, I am Paolo Landrini. I'm Mac account manager for GM International. And as GM International is bringing this webinar to you today, let me take a few moments to introduce GM International to you. Let's go to the next slide, Bob, please. We are a safety company, meaning we manufacture, design, engineer, manufacture a complete range of intrinsically safe and SEAL certified interfaces and devices, which are used in automation packages such as DCS, ESD, fire and gas, SCADA, and so on in various sectors, primarily oil and gas, petrochem, pharmaceutical, food and bev, and so on. We've been around for a long time, more than 40 years, and we're very proud to manufacture all our products here in our headquarters near Milan, Italy. On the other hand, we're a global player present in all the continent throughout offices, direct sales offices or subsidiaries, one of which is in Houston, and many distributors. And we do a lot of, besides selling product, and do a lot of installations on, plants all around the world. We also provide services, as you will see in the next slide. So we provide functional safety, EX, and cybersecurity training and classes. Because we make safety products, we take special care in manufacturing those products, for our state-of-the-art facility. We have full traceability, 100% testing. We guarantee the product for 5 years. And we do this because we care about, the environment, the people that work in the factory that use our product. After all, our product provides for the availability and safety of those plants. Next, Bob. But you cannot take my word for it. So you can see we have certification, global certification. We have over 15 agencies, such as FM, UL, DNV, certifying our product and our facility. In fact, we have, I cannot count how many, but 3 to 4 inspections for each of these agencies a year in our facility. We also functional safety management, C3 certified. So not only the product certified, but also our design, engineering, testing, and so on. ISO 9000, 45000, 14000, and so on. No issue, bro. We basically follow all the rules. And these are the products that we manufacture. IS barrier, up to C3. We have safety relays with and without line monitoring, also C3 certified. We have a line of isolator, differentiating from others that we have SEAL certification on those, SEAL 2 and SEAL 3. Same for power supply. We have EX and SEAL certified power supply. The SEAL 3 certified power supply. A real certification for power supply from head to toe. Multiplexer, a line of multiplexers, so temperature, digital, HART multiplexer. We have a line of termination board, which are designed to interface with the most common ESD and DCS system out there, SPD, search line protection, indicators, and so on. These are some of our customers. So basically, we supply our product to the NAC or the system integrator. We mentioned them all because they're all our customers there, the main, ABB to Yokogawa. Many EPC use our product in their project, and we are also very proud to supply to OEMs, people that makes machines, drilling rigs, printing machine, really well-at packages and so on. And we are on the list of many end user. Yeah, I put some logo there to make some color in the presentation. some of the oil and gas company will use our product. But this is it for me. Now, before next Bob, it's I guess it's the beginning of the presentation. Yes, guys, before Bob starts, let me tell you that you have a possibility to ask questions through the question and answer box. We will also answer the question you pose through the registration process at the end of this webinar. So before the end of the webinar.
Right.
Okay, Bob.
All right. Well, thank you, Paolo. Appreciate it very much, and thank you all very much for joining us today. And hope you're all ready for the holidays. So yeah, I know it's getting very festive here in Houston, and Christmas lights are out and all that good stuff. So wishing you all happy holidays, however you celebrate it, wherever you guys are located. So today we're going to talk about various EX protection concepts, if you will. This is always I think, a fun discussion to have, because in many cases we think that this is the way we must go, or this is really our only option that we can use. And in reality, when we start looking deeper at the relevant IEC standards as far as protection concepts, we're actually finding that there may be different options that we can look at. Obviously, GMI is a manufacturer of intrinsic safety, and it's a very popular protection concept, but there are some areas in which intrinsic safety is just not suitable. So we want to talk about some of these other protection concepts. What are the pros and cons? What are some of the more positive things, or maybe some of the negative things from a long-term perspective, from an owner's perspective, as well as a system integrator perspective? What are some of the things that we really want to look out for? Because we really want to focus our project opportunities, if you will, on total cost of ownership. And there are certain things that, depending on the EX protection concept, that some of them have, some major drawbacks, if you will. Some of them have certain real good distinct advantages. And there's never necessarily one methodology, if you will, that's suitable, really, that I would say hands down is absolutely, this is the only way to go, or the way to do it. So again, this is based upon my opinion, and you as users and operators and designers and engineers, you're going to have different opinions, which is good. But at least I wanted to bring up some of these things that I see, because again, as Paolo mentioned, we distribute products, but we also do inspections, we do training, we do a lot of different things in the EX world. And I've seen a lot of good, bad, and ugly with regards to some of the EX equipment that's actually out there. So in order to have an explosion, right, we have three legs of the triangle. We've learned this from day one. In order to have an explosion, we have to have a source of ignition, which could be an arc or spark, it could be heat. We need to have air or oxygen in some form, and then we have to have some sort of explosive material. When we combine all three of these legs of the triangle, that's our danger zone. That's where we're going to have an explosion. So if you think about all the protection concepts that we're going to talk about, basically the protection concepts are there to eliminate or reduce or minimize one or more of those legs of the triangle. That's basically what we're doing with the various 60079 protection concepts. Now we more or less break it down, and again, all types of energy can be sources of ignition. So we more or less, all the protection concepts are really broken down into four major categories on how they protect. There's what is called energy limitation, and the one that we know best is intrinsic safety. This is limiting the amount of energy that could actually create an arc or spark in a hazardous location. So as long as we stay below that energy limit, we're A-okay. Non-sparking, again, we're removing a sparking element. This is commonly the main protection concept we use here is increased safety. Containment, this is where we're not eliminating any of the legs, but we're basically containing it within an enclosure. This is basically known as flame-proof and some other ones as well. And then separation, where we're more or less removing one or more of the legs from the other ones. So pressurization, pressurized panels, cabinets is a protection concept that is widely used for separation. For dust hazards, we have basically two main categories of protection. Excuse me. Energy limitation, again, intrinsic safety, and then separation, where we call it dust ignition proof, pressurization, and others. And again, the details on these protection concepts are within the 60079 standards. And by the way, there are some new things that are going to be coming out next year in 2024. The new edition of the Dash 14 standard, which is the installation design standard, is going to be introduced sometime, hopefully early next year. And we're getting some feedback as to some of the things that are in it, which is very interesting. And I expect that we'll have a webinar on that at some point in time in early next year. And then also the new IEC TS 60079-44 personal competency has actually now been, I think it's been published. I'm not sure if it has actually now been published, but it's if it hasn't been, it's very, very close. And here's a note, as the user of EX equipment, you don't necessarily need to know all of the specific 60079 standards, but the application of these standards is a must.
Yeah.
Excuse me. Get
No,
to the next.
nothing about sorry.
So the EX protection concepts, if you will, these are more or less, and it's not every single one of them, but it's the majority of them. We break it down into these main protection concepts, and you'll see at the end of these protection concepts now, where historically we had EXD, that's now known as EXDB. We used to have EXE for increased safety. It's now known as EB. And you'll see some shifting around of some of these protection concepts, if you will. There's been a change afoot over the last few years to include what is called the EPL letter at the end of protection concepts to give a little bit more clarity, if you will, as to the suitability of these protection concepts for the particular zone in which they are to be used. Over on the right-hand side are the relevant IEC and EN standards that will tell you all the details of flame-proof, which is located in Dash 1, increased safety in Dash 7. Again, as an application engineer, depending on your role, you may be as a manufacturer. Well, you as a manufacturer need to understand those standards very, very closely. But as an application engineer, you don't necessarily need to know all of the details within those standards, but you need to know how to apply this equipment in hazardous locations. Excuse me. So going through some of these protection concepts. So energy limitation, intrinsic safety. What we're doing here, we're minimizing or limiting the amount of energy levels below the MIE, the minimum ignition energy for the particular gas group environment. Every gas out there has different amounts of energy that it takes to ignite. Gases like acetylene and hydrogen take a very, very small amount of energy. So therefore, we have to be extremely concerned about energy limitation. And so this is actually one of the drawbacks about intrinsic safety is that the tolerance is very, very close for things like acetylene and hydrogen. And we did have a question about hydrogen, which we'll talk about a little bit later on in our Q&A session. We have three different levels of intrinsic safety, IA, IB, and IC, and this is based upon the fault tolerance. So anything that you see with an A at the end of it is going to be suitable for zone 0, 1, and 2. If it has a B at the end of it, it's good for zone 1 and 2. If it has a C at the end of it, it's only suitable for zone 2. So non-sparking, commonly used for increased safety junction boxes, where we're basically housing terminal blocks that are not considered to be arcing devices, but we build these with certain creepage and clearance distances, making sure that these terminals are such to where connections cannot come loose over time. And we make sure that there is no potential arcing or sparking that's taking place on the inside of these enclosures. So again, we're reducing, if you will, the arc we still have heat that we have to be concerned with, but there is no arcing going on, hopefully, within the design of these enclosures. Non-sparking, which was formerly known as EXNA, is now known as EXEC, which is a lesser form of EXE, in which now is known as EXEB. Hopefully that makes sense. So EXE is now known as EXEB. Now, this is a poll question, and this is actually not a question that we've covered. And I realized that this morning, but we'll just leave it in there anyway. Just to see how,
let's test our guest, see if they have any idea. Yeah, you have not spoken about this. As I was about to launch it, I said, flashpoint. We didn't talk about flashpoint. So what is the definition of a flashpoint? Only
Well-
one of these questions is correct. This answer is correct. So we have a temperature in which a gas or vapor will spontaneously ignite, or a temperature in which flammable liquid will turn into a flammable gas, or ignition temperature at which point the gas will explode, or the point at which a flammable solid will become liquid. Well, this last one doesn't sound right, Bob. I will describe this for sure.
Yeah,
But,
we can remove D from the answers. So it's either A, B, or C.
Okay, so let's see. We're doing good on time. Let's give them a few more moments. A couple more seconds for you guys to answer. We will not judge you, and in fact, we don't see who is answering. We just see the percentage and the number of answers.
And I'd love to say we use this as a way for you to see if you're paying attention, but of course I have not talked about flashpoints. So
But alert, make sure they still you're awake. Okay. Okay, let's do it. Let's and we have a mixed answer. I will show you that.
okay.
You guys see it? Yeah.
Yep.
A,
So
B, C. But I guess, in my guess, is the one with the most answer, which is B, right?
that is correct. So
Which is the
yes,
correct answer.
flashpoint is that temperature in which a flammable liquid will turn into a flammable gas. So if you think about, for example, on the inside of a tank that's holding flammable liquids, we don't consider actually where the liquid is at that level. Anything below the liquid level, if you will, that's a non-hazardous area. However, the area right above the flammable liquids, in which if we're above its flash point, now it will emit a level or an amount of gaseous vapors, if you will, those will ignite. And we consider that area a zone 0 because that's an area in which there is a continuous release of flammable vapors into the atmosphere, if you will. So yes, B is the correct temperature or correct answer. The answer to A, temperature in which a gas or vapor will spontaneously ignite, is considered to be the ignition temperature. So when we do a lot of the training and the various courses we do, we talk about this at length and give you some examples, and we actually do some of this stuff, practical stuff, which is always kind of fun. Okay, so moving on here on EX protection concepts examples, here's containment. So containment we commonly refer to as flameproof, and that's the most common protection method that we use for containment. Here we're taking the arcing and sparking components, general purpose components, we're placing them inside of a flameproof box, and we allow an explosion to take place. However, we cool off that hot flaming gas by the use of flameproof joints. They could be flanged, they could be threaded. There's many different types of flameproof joints that you could actually use. But the whole idea here is that we make sure we cool off those hot flaming gases and make sure that none of the materials inside will be transmitted to the outside that potentially could ignite the gas surrounding the enclosure. So flameproof is one example. Powder filled, EXQ, is actually another example of a containment type concept. Enclosed break, EXNC, now known as EXDC, is a lesser form of flameproof. So these, again, they contain the explosions, do not allow the hot flaming gases to ignite the surrounding atmosphere. Then, of course, we move into separation. So the one that commonly people think about is pressurization, where we pressurize a panel. We're keeping the pressure on the inside of an enclosure or a light or whatever it is at a level that's slightly above outside atmospheric pressure. Generally, it's about 0.5 millibar or greater. And at that point, we're making sure that no flammable gases or vapors can actually get to the inside where the arcing and sparking or heat producing type devices are located. So very commonly used for complex panels where maybe we don't want to put them in big, heavy cast flame-proof type enclosures. Very, very good popular methodology. But we also have things like hermetically sealed. We have oil immersion. There's actually a concept called restricted breathing, EXNR. These all operate on the fashion of separating, keeping our flammable mixture away from either a heat source of heat or a source of ignition through sparks or arcs. So what you see down on the bottom, you'll see a little ballast there. A lot of times ballast in old fluorescent lighting, they would actually encapsulate this in a resin. So the printed circuit board would actually be incapable, if you will, for coming into contact with the explosive gases or vapors. So what are some of the things that we need to know beforehand before we actually figure out exactly which protection concept is the best, right? So what zone is the equipment to be placed? Well, if it's zone 0, we're really limited to only EXIA and MA as our protection concepts. There aren't other protection concepts that are suitable in general for zone 0 other than intrinsic safety or encapsulation. So if we're going into a zone 0, well, we're pretty much limited to those two different protection concepts. What gas groups are we dealing with? Certain concepts are not gas group dependent, while others are. For example, flame-proof. You're limited with regards to flame-proof enclosures for 2C applications because 2C has extremely volatile gases, high flame speeds. So therefore, certain enclosures are not suitable for 2C gases, but may be suitable for 2A or 2B. What's our temperature code? Every piece of equipment and every gas vapor out there is going to have a temperature code assigned to it. Certain gases have extremely high temperatures, such as like methane for LNG. They're a T1 gas. Pretty much any piece of EX equipment from a temperature code standpoint can be used in a methane environment based upon this factor. Other gases have extremely low temperature codes, which will limit heat producing type equipment such as lighting and transformers. So we have to take that into account. What is our T codes associated with the gases and vapors that we're actually having to deal with? And then finally, what is the ambient requirement? This is one thing that gets overlooked quite a bit, quite frankly. The standard range for EX equipment is -20 to +40 if it's not marked. However, we certainly find in applications here in the US where it can get above 40 degrees C during the summertime off the Gulf Coast offshore. It might get up to +40, even +50. And certainly places in the Middle East and South America, you could see +50, even +60 degrees C. So the one thing that we have to remember is that our protection concepts and our products are rated for a particular ambient, and we cannot allow our use of those products that are not suitable based upon ambient requirements. And again, certain protection concepts are not as adversely affected by this as others.
We have another poll,
So
Mark.
here's another poll question we've got.
Which protection concept safety constitute? Which is quenching or cooling of the gas vapor, removing the explosive vapor from relevant surfaces, or limiting the amount of energy, or eliminating or reducing the heat and spark in hazardous area. These are the four methods. Only one is correct and should be an easy answer because Bob gave this away to the.
We did cover this one, yeah.
You did cover it, and in fact, so far I see every answer coming in is correct. Well, not everyone. but almost everyone. Good. Let's it's
Sure.
clicking away, so let's give it another moment.
Okay.
Okay, let me end it to show it to you. 19+% of you answer correctly, which was limiting the amount of energy that can be released into the hazardous area. Right,
Yeah.
Paul?
That's right. That's right. And to give you an indication of how much energy we're talking about, for example, a lot of gases and vapors that we talked about the MIE, the minimum ignition energy. For many gases and vapors, it might be in the 200 to 300 microjoule range. When we talk about things like hydrogen and we talk about acetylene, now we're talking about 18 and 19 microjoules. That's enough energy that if I actually held an arcing or sparking at, say, 19 microjoules right up here, right now, you probably would not be able to actually see the spark. It's actually that small. It's that low amount of energy. And I know we're talking in the EX world and not just the EX world about the use of hydrogen as a fuel of the future. And I don't think a lot of people are necessarily thinking about some of the key factors about hydrogen, about how dangerous it truly is for various reasons. But we'll talk about it a little bit later on in the Q&A because I think we had a question on that a little bit later on. So a couple generalities with regards to selection of EX protection concepts, right? So intrinsic safety is power limiting. So realistically, we're limited to about 1 watt of energy or less. So if we have a motor starter, we have a light fitting, we cannot make those operating on 1 watt. So things like motor starters, light fittings, we're going to have to use different types of protection concepts. Increased safety is not gas group dependent, so we can use it in all gas groups. That's a positive thing. And generally, it's most of your increased safety equipment because there is no arcing or sparking. It will generate heat, but we're pretty much down at the T6 or T5 range or below. So that also lends itself very nicely to a lot of gases and vapors that have fairly low temperature codes. Some concepts like encapsulation, sand filled, are generally at the component level and not, and generally you don't find a complete device that maybe is encapsulated other than certain exceptions of maybe small little devices such as solenoid valves. You'll find things like quartz or sand filled, like I showed in that picture before of a ballast. That's going to be incorporated into another product such as a light fitting. Same thing holds true for encapsulation. We might find fuses that will be encapsulated, and we'll take that fuse and we might put that inside of an increased safety enclosure. Certain things like non-sparking, we'll also find that maybe where we'll find PLCs or control systems that will be EXNA, but we need to make them suitable for zone 1. Then we take that and combine that with maybe a pressurized enclosure to make it suitable. So some of the protection concepts are more standalone. Others are more at the component level. Just kind of keep that in mind. One of the big advantages of flame-proof and pressurization do allow the use of non-EX equipment to be used in hazardous areas. So this is a big benefit. Intrinsic safety also does to an extent. The definition there is that if the ISN device is what is considered to be a simple device, meaning basically non-energy storing, then we can in fact use general purpose things like switches or an RTD in a hazardous area, as long as we're protecting it upstream by the use of an intrinsically safe barrier. We do not necessarily require that end device to be certified. And again, legacy EXN type equipment is limited to zone 2 only. So we cannot use those types of pieces of equipment in zone 0 or zone 1. So now that we have kind of a better understanding of some of the good, bad, or ugly of what we can and cannot do, let's maybe take a look at some of the advantages and disadvantages. So advantages of flame-proof, it's very easy to apply. We can make almost any electrical component suitable for hazardous locations. It is a robust construction. It can be cost-effective depending on the product involved, and it's fairly simple to combine with other techniques. So for example, a motor, you will very commonly find an EXD motor that will actually have an EXE terminal box mounted to it. So you've actually got a combination of protection concepts. So now we're combining different protection concepts with flame-proof. That panel that you see over on the right-hand side, you have a flame-proof enclosure on the top. You have an increased safety enclosure on the bottom. All of your arcing components would go on the top enclosure. Your non-arcing components would go in the bottom enclosure, and that would be a complete assembly that would be rated EXDB EB. So what are some of the downsides of flame-proof? And there's a lot. You can see over on the right-hand side, omission of things like bolts, right? Or we don't tighten them down tight enough. If we do something to the flame-proof joint, we scratch it, it wears out due to corrosion. We've now violated our protection concept. The wrong corrosion protection. We make a lot of flame-proof enclosures out of various materials, but some materials are not very suitable for extreme environments. Maybe the marine markets, an aluminum enclosure may last okay for about 5 years, but after that, it starts falling apart. Again, I mentioned scratches, obstacles. We mount these enclosures. We have to remind ourselves to make sure that we leave ourselves a certain distance between the flat flange, flame-proof flat joint, if you will, to not allow pressure piling to take place. Maybe we don't use the right glands and stopping plugs. Again, improperly installed cable glands, they are heavy, they're difficult to service. If we make changes to the contents of the EXD box, we very well could violate the certification. And then finally, a U component certificate. This is where we buy an empty enclosure and we just assume we can put all kinds of arcing and sparking components on the inside. And so we buy an empty enclosure from a manufacturer that will have a U certificate. We cannot use a U certified product unless it's undergone further evaluation. This is one thing that I see all the time. I see U certified components that people have just done field assembly, and you cannot do that. That's spelled out very clearly in the Dash 14 standard. That holds true for pressurization, that holds true for increased safety, and it certainly holds true for flame-proof as well. So some of the advantages of increased safety, it's lightweight. We can use a GRP type material or sheet stainless steel. It's not gas group dependent. Again, lower T codes. It's generally easier cable gland installation, and it can be a lower cost depending on the product and the application. However, there are some downsides, missing bolts, but these are usually easy to fix in the standpoint that a missing bolt on an EXE enclosure isn't really going to negatively affect its EX protection too much like it would on a flame-proof enclosure. So we'd certainly want to replace those. However, we could damage the seals. Well, we now no longer maintain our IP codes. Bolts over tightened, again, using the wrong blind plugs and cable glands, make changes to the contents. So now we're adding maybe more terminals or non-EX components. Inside of an EXE box, we cannot use anything other than what is an EX certified component. We can't just take a standard off-the-shelf relay or a contactor and put them inside of an EXE box because there is no protection, and there's that U component certificate as well. So what are the advantages of pressurization? We can use enclosures that are more similar to our industrial panels. It looks very similar in concept to our general purpose type equipment. And again, we can use general purpose equipment in hazardous area. It's generally not gas group dependent. We can also incorporate cooling features for high ambient applications. We can now incorporate things like vortex coolers, or we can incorporate things like standard off-the-shelf space heaters on the inside of these enclosures. Again, these are well suited for things like PLCs or HMIs and similar type equipment. And we can actually pressurize entire buildings or cabins, if you will, using the concept EXPV, which is very similar to the protection concept PX, PY, and PZ. Some of the downsides, poor sealing, which allows the air to escape freely. It does require monitoring via an alarm and may involve automatic shutoff of the equipment. This is true for EXPX systems for Zone 1. We need to have quality of the air. If we're bringing in bad air, then this can start damaging the components. And certainly we need to have air available for pressurization. And then, of course, adding components after certification. So there are some drawbacks with pressurization as well. Some of the advantages of increased, actually this should say intrinsic safety. When it is selected properly, it is the safest EX protection concept. And again, it does allow the use of non-EX certified equipment within a Zone 0. It can be extremely cost effective. It generally is the best solution for low voltage instrumentation circuits. There is little maintenance involved once it's designed properly. However, there are some negatives with intrinsic safety. It does involve more engineering. We need to basically match, if you will, the associated apparatus to the end device. And this is very, very important. We have to take a look at the entity parameters of our devices and our associated apparatus, the barrier, to make sure that they match. Again, we're limited in energy to the MIE of the gas group. It's fairly simple to defeat or bypass intrinsic safety. If a barrier actually blows a fuse, it's not uncommon, and I've seen this, where people will actually just take a conductor and bypass the barrier itself. And at that point, we have basically have no protection whatsoever. A very, very dangerous situation. It does require for Zener barriers a dedicated clean earth, if you will, and there are some strict requirements for wiring and segregation between IS and non-IS. So what you see over there on the panel on the right-hand side, you'll see some wiring that's going on. It came out from the factory, no problems, but then when it gets into the field, people basically have kind of defeated the purpose of IS by not following the requirements as far as installations and separation of IS and non-IS circuits. So again, IS is very effective and it's very safe when it's properly used, but in many cases it does get defeated, or ignorance, we just make mistakes, and we don't want to do that. So what are some of the deciding factors? Going into Zone 0, IS is really the protection concept of choice. But again, a Zone 0 is typically those areas inside of a tank. We're not going to be putting in high voltage electrical equipment generally inside of a tank. We're going to be putting in things like sensors. So IS makes sense for that application. For Zone 1, if a component exists that has its EX certification, it may be more beneficial to consider multiple protection concepts, such as an EXDE control station. If an EX component is not available, it may make more sense to consider either EXD or EXP. So an EXDE control station, for example, the enclosure is increased safety, but the actual switch itself on the inside is a flame-proof switch. We've combined two protection concepts to make it suitable for Zone 1. That makes perfect sense, widely used. However, if we couldn't find a switch that's actually rated, then our second option would be to say, well, let's put it inside of a D enclosure. Then we don't have to use a certified switch. And again, if air is not available, then EXD probably makes the best sense for those types of applications. And then the other factor, what is the quality of my installers? Certain protection concepts rely on a higher level of competency versus others. For example, increased safety. One of the things that people fail on increased safety is the length of the conductors that we actually can run on the inside of an increased safety box. Because increased safety is relying upon the protection concept of eliminating or reducing heat. So it's not uncommon that an electrical contractor, if he wants to have some spare wires, he's going to do service loops on the inside of EXE enclosures. We cannot do that with an EXE enclosure. We can do that all day with an EXD enclosure or an EXP enclosure. But because we have to limit the amount of heat that's built up on the inside of EXE enclosures, the installer has to take extra precautions when doing EXE installations. So you have to understand, again, who are the people that are actually going to be putting this together? Do they understand the protection concept? Do they understand the limitations and some of the drawbacks of one versus another? Sometimes you'll actually see products that will actually come out that actually have the ability to be installed in different fashions. Now, the one on the left-hand side, again, is an example of a combination of EXD and EXE. That's fairly straightforward. However, the product on the right-hand side, if you notice, you'll actually have EXD rating. It also has an EXI rating, and it also has an EXNA rating. So depending on how this product is applied, this product can actually be installed either as intrinsic safety, which has certain requirements, or I can install it as flame-proof, which will have certain requirements for glanding and cabling, or I can install it as an EXNA product, which has, again, different installation requirements. This is one of the things that I see when I'm doing inspections. I'll see products like this, and then I have to do a little bit of digging to find out, hey, is this intrinsic safety? Were they running blue cabling, or are they marking the cables intrinsically safe, or is there an associated apparatus associated with this product? In some cases, no. If it's not, okay, well, are we going EXD? Are we using an EXD gland? So forth and so on. So it's very important to understand if you're designing something, right, and you're saying, I'm going to select this particular IP converter unit, to also make sure that people understand, whoever is doing the installation realizes, how are we going to be doing this installation? Are we going to be doing it intrinsically safe? Are we going to be doing it flame proof? Or how are we going to do this? And make sure our instructions are clear. Oops. Some of the other drawbacks, deciding factors, right? And a lot of it comes down to things like cable glands. If we go with D type enclosures, in many cases, we might have to use what is considered to be a barrier gland. Well, barrier glands are very labor intensive, and they sometimes can be difficult to install. Now, manufacturers have gotten much better with regards to their design of barrier glands to make it simpler and make it more foolproof, if you will. But we don't want to do things like on the bottom left-hand side, build up the cable to make sure that the glands actually fit, or have issues where we're putting things like Teflon tape or tape on the threads going into a flame-proof enclosure. That's a violation. Up on the top right-hand side, we have a plastic gland that's going into a flame-proof enclosure. Well, maybe did we use this, like I showed on the slide before, as intrinsic safety? Well, if we did, I don't see any markings on this cable that's telling me it's intrinsically safe. And then finally, the use of shrouds and things like that, where we're actually covering up some of the issues. Generally we want to try to steer away from those types of things. So to summarize, some generalities do exist. And you see some similarities with these protection concepts. And again, material costs are really only one factor to consider. The considerations, I think, are the installed cost, how easy it is to install it, ease of maintenance, again, the skill set of the operators present, availability of replacement components, and certainly technical support from the manufacturer. And again, this is the one thing that I always tell people and designers when we get into it early stages. Don't just think about an application thinking that a particular EX protection concept is the only way forward. There are many different protection concepts that are being used and being introduced almost on a daily basis. Not necessarily protection concepts, but products that are using multiple different protection concepts. And manufacturers are getting very creative with using these protection concepts to make it more cost effective, to make it easier to maintain, to easier to service, right? So keep that in mind. Always look at those types of things, what manufacturers are doing. And again, if you're responsible for building products, take a look at those standards, kind of figure out a way, hey, can we encapsulate this component? Maybe if we do that, then we don't have to use a flame-proof enclosure, or we could do something else, or a combination. So again, if you kind of have an open mind with some of this stuff, you can really create some wonderful solutions and make things much easier for people moving forward.
Yeah, we
I
have
think
one more
this is our
poll.
last poll question.
I guess so. It's U meaning at the end of the EX certificate. What does that mean? It's a condition for safe use of EX equipment. The equipment as a component certification only, or the equipment is certified for use in areas involving hydrogen, or the equipment is approved for use in Europe. That's a good one, Bob. But it should be EU,
I
not just.
did cover this one.
You did cover the last one. It sounds, yeah, but yeah, I appreciate your presentation so far, Bob. And as you said, there are the different factors that will lead you to select a certain protection method versus another.
Yeah.
You
Yeah,
said,
it's not uncommon. I'll see, Houston is very much kind of the hub where we see projects that are being executed all over the world. And I'll see a project that's going on in Australia, and they'll have a certain protection concept that they'll lean heavily on. And then all of a sudden I'll see a very similar type project that might be going on in someplace in the Middle East. And all of a sudden they're looking at it from a different perspective, using different protection concepts. They're still getting to the same place, it's still the same type of area classification, but they just look at it in a different perspective. And that's great. It's not a one size fits all. It's based upon experience, it's based upon the environment, it's based upon the knowledge of the designer, the engineer, whatever it is.
well, one decision factor is, the area classification. I mean, if it's a zone 0, for example, can you put an EXP enclosure in zone 0?
No, no. So yeah, for a zone 0, you're pretty much limited to intrinsic safety, which call follow, right? Or encapsulation. But yeah,
But
when you get
also, other methods, for example, you mentioned earlier, you talked about EXN. That sounded like a most wonderful, protection method, but in reality, it's limited to zone 2, right?
that's correct. That's correct.
So it depends, much depends on the area you're classified. Okay, so let's just see. You see the answer? Yes. So the correct answer was the equipment as a component certification only.
That's correct.
So I guess we had our 50-50. So guys, maybe you were not so attentive, or we were not as good as at explaining it.
That's
Okay,
blame the instructor. It's quite all right.
always blame the instructor.
That's
So
right.
I think we answered the question here. If a PLC could be stored in a cabinet, EXP cabinet, yes, a general PLC can, but not in zone 0 because EXP cannot go in zone 0. It could be only limited to zone 1, right?
Yes, and I didn't see the question, but you said
It
pressurization?
said if I could put a generic PLC in EXP enclosure, yes, you can, of course,
Yes.
but in zone 0, no, because EXP cannot go to zone 0.
No, you could, that would, for zone 1, you would call that an EXPXB pressurization, where you're taking general purpose components and putting them into a zone 1. If you took a zone 2 PLC or HMI and wanted to put that in a zone 1, that's called a PYB pressurization technique. So yeah, but neither one of those are suitable for zone 0. And in reality, again, zone 0 is going to be an area in which it's going to be inside of a tank where there's a continuous vapor gas present. Generally speaking, that's not a work area. That's not an area in which workers should be hanging around in. So I don't know why you would want to put a PLC or an HMI in that type of environment in the first place.
But you can have devices like radar, level.
Yeah. I mean, level detectors and everything else, and you could have. There's actually equipment that you'll see that is actually. We don't have it in part of this presentation, but I'll try to explain it very briefly. You can have a product that'll mark EXD with a /IA, meaning that half of the product is certified D, the other half of the product is IA. So that could be very much some sort of sensor detector transmitter or something like that, where maybe the probe is located inside of a tank, where the housing could be located outside of the tank. So it's actually a demarcation, if you will. So that's something you don't see too terribly often. But if you see something that's marked, say for example, EXDB/IA, that's what that is basically meaning. That half of the product can be installed in a zone 0, would have to be protected by intrinsically safe. The other half of the product would be flame proof, and we would need to use a flame proof gland along with the cabling that's intrinsically safe for that particular device. So there's some little unique solutions that are out there, and they exist.
Okay.
So just to finish up on these slides, yeah, we'll get into the Q&A because we don't want you to leave just yet. But we do have some SIL wall charts available, and we also have some EX wall charts that if anybody would like, we'd be happy to get these to you.
Okay, let's go on, Bob, so we can go to the next presentation because we have only 10 minutes left.
Okay. Oh, I'm getting it.
Unless we have a few more slides. We have a few more slides going?
I think so. Closing. That's us.
Just us. Okay, good. Let me see if I can share.
And I'll stop sharing.
Yeah, let me see if I can share the presentation. See what happened. Nope, didn't do it right.
Well, no worries. I can bring mine up.
Okay, now it's on, right?
Yes.
You guys see? Okay.
I see it.
Well, before we start, we have a live question. It says, we are using the HMI Siemens, which confirm EX certified for the manufacturer. So can we install this HMI inside the non-EX enclosure? I guess it depends on the certification of the HMI, no?
Yeah, so generally speaking, a lot of the HMIs or PLCs, they will have an EXNA or now what is called EXE certification, EXEC certification, meaning that they're suitable for zone 2. What they will have in their certificate, they will state something to the effect of must be installed in an enclosure that meets the requirements of 60079- well, it could be 15 for the old N standard or 7 for the increased safety standard. So yes, you could do it. You just have to look and see what the Siemens PLC is actually stating as far as their conditions for safe use. And you'll find that information in the installation operations manual, as well as you'll find it in the copy of their certificate.
Good. Thank you, Bob. How do we handle communication in hazardous location?
Yeah, ion. So yeah, there's many different options that exist for communications in hazardous areas, telephones, tablets, other devices. You know, here's the important thing to note. It's important to understand not to take general purpose equipment into a hazardous area unless we have a gas-free permit or a work process in place to be able to bring those devices. And there's even some manufacturers that will sell what they call EX cases for things like iPhones and tablets that they call them intrinsically safe, but they're actually not. They're just cases. They make them suitable for zone 2, but they're not considered to be intrinsically safe. But you'll find things now like VR headsets that's a wireless access point. You know, just want to be careful that we're not taking our ordinary location equipment into a hazardous area unless we have a gas-free permit and we're following the procedures of whatever it is in that facility. So things like key fobs or anything like that, those are all potentially a source of ignition.
For example, you see all those videos, on YouTube or whatever, or using a telephone in an hazardous location, which is a gas station. People don't realize the gas station is hazardous there. And then, boom, they get a fire started.
Yeah, absolutely. Okay. You gotta be careful.
When and where ATEX classified area become non-classified, and what type of wiring is allowed under ATEX? Oh, that's an interesting question.
Yeah. So under ATEX, I mean, ATEX is the European directive that we follow for hazardous locations, right? And there's two directives. Well, basically, the standard for area classification that we follow under the directive is the EN 60079-10-1, which is a risk assessment basis, and it's based upon the sources of release. So here's an example. If we have a flanged pipe, which is processing a flammable liquid that's passing through, or it's got a flammable liquid on the inside, anywhere that we have that flange, we would consider that to be a zone 2 under a source of release. It's an area in which we would not normally expect a flammable release to take place. However, under abnormal or unusual circumstances, it could. However, if we change this pipe to a solid pipe without flanges, we could change the area classification now to non-hazardous. The other thing that we can do, and this is more common, is that if we start introducing ventilation, it could be natural or forced ventilation, we can also reduce the potential sources of release and reclassify the area to a lesser hazard. Here's the important thing to note. By doing that, we want to make sure that we're not violating whatever the regulators have approved us to be able to do. And what does the regulators say in that particular environment? Will they allow us to do that? So generally, when we're doing either reclassification or during the initial area classification, it really is something that should involve all disciplines, including the mechanical, piping, electrical, and management within an organization to make a full-blown area classification review. And anytime we make changes to that, we should also be doing the same thing. As far as wiring methods, under ATEX, we follow the 60079-14 standard for installation design, which allows the use of cables, armored cables, unarmored cables, conduit, other types of installation details. So there's a lot of freedom and flexibility. Only thing I would say here is that we have to make sure that we also make sure that we follow each country in Europe, whatever their specific wiring regulations are. So, for example, in the UK, they're going to also follow the BS 7671 standard for general wiring. So we need to not only follow the HAZLOC wiring requirements, then we also have to follow the general wiring requirements. So there may be some things in there that will be a little bit more restrictions or a little bit more onerous. But basically, if we follow the 14 standard, that will get us probably 95% there.
Of course, we always have to follow all the regulations, on top of, for example, if, fire department regulation, maybe, the type of fire hazard that you can create with the plastic of the cable,
Oh yeah,
might
yeah,
not be
fire
defined.
ratings. Yeah,
Yeah, it might not be defined in ITX regulation, but it's still something you have to follow.
yeah,
Okay.
absolutely.
Although, honestly, now UK is no longer following ATEX,
That's right. Yeah. Well, they have postponed the UKCS
Yeah, you're right. To
application
next
now,
year.
so
End
it's
of 2024, I believe.
yeah, yeah,
How to
great.
use IS in zone 0 and how to check failure. Can we
Right.
also repair an IS item and return back to service? That second part I can answer you is definitely not, but you go
Well,
ahead.
yeah, you can't put it back into service. So what's going to fail on an intrinsically safe barrier is typically a fuse. That's going to be the fail safe item or the device that's going to fail. You're going to blow a fuse. So the way you actually check it, you would take a meter and you would check for resistance. You would take it out of service, if you will. You don't want to test it while it's in service because you could generate a potential arc or spark by doing it. So we want to take it out of service, and then we would check for resistance. And if we have an infinity on one leg, then we know we've blown a fuse. That's typical. This is one thing just to highlight. It's important to note, right? Certain products will have, for example, EXIA. That means that that's the end device, and that can be installed in a zone 0. What you will find on intrinsically safe associated apparatus is you'll find something where it's in brackets, EXIA, like what you see below there. That means that that's the associated apparatus that is feeding into that end device. I cannot install the associated apparatus into a zone 0, but the output is suitable for use into a zone 0, if that makes sense.
Sure does, Paul. And in fact, the repair issue, an IS product must be returned to the manufacturer for repair because we need to retest and re-verify that the product is still suitable. There is an isolation test to be done. Also, components that are specifically being selected for that product and tested. So the brand, the manufacturer, the type, maybe there is a special test on the dial before it's installed. So they need, but thanks God, the failure rate of IS barrier is very, 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 very low. In fact, ours is too low. Which EX protection is best for hydrogen application? Hydrogen, as you mentioned, is a very nasty gas.
Yeah, yeah. So hydrogen is one of the most difficult ones to deal with. So part of the reason why it's so difficult is that it has a very, very broad explosive range of anywhere from 4% to 77%. Hydrogen, if it's present, it will ignite. Again, it doesn't take much energy to ignite. It has a very fast flame speed. When it does ignite, it's a 2C gas. The one thing that is positive about hydrogen, it takes a very high ignition temperature. I think it's like 460 degrees C before it will spontaneously ignite. It is plentiful and very efficient. Flame proof is an issue in finding equipment with a 2B plus H2 rating. There are more and more products out there that are rated for that. Certainly, IS is limited in the amount of power let through. It may result in shorter cable lengths, that we have to take that into account, the storage of energy within our cable on IS. So if we store too much energy and release it, then that could be above the MIE. So maybe our cable lengths are going to be a little bit shorter with hydrogen applications. Non-sparking increased safety, very suitable, but we do need to take into those accounts of hydrogen when selecting EX equipment for sure. And hydrogen is a lighter than air gas. So generally speaking, if we have good ventilation, hydrogen will dissipate into the environment very quickly. So that's a positive thing about hydrogen, because it is lighter than air, and we use it and it's released into the outdoor environment, then we're A-OK. That's a picture of the Hindenburg that blew up many, many years ago. And actually, what was really the cause of ignition was a lightning strike onto the tower, which ignited the paint that was used on the outside of the Hindenburg, which then it was a flammable paint, if you will, and that ignited the hydrogen on the inside. It wasn't actually the direct strike onto the hydrogen, it was actually the paint that was used on the outside of the Zeppelin, so to speak.
Yeah, hydrogen, it's also very volatile, very difficult to contain. Okay,
Very
we
much
have a
so.
couple of last questions here. Let me see if we can get to those. We're now using non-EX certified thermosensor in an IS circuit. Can we consider this sensor a simple apparatus, or we need to, certify them basically? Well, I guess it depends on thermosensor what they mean. If it's a thermocouple, yes. RTD, yes.
Yeah, it depends. Yeah, that sensor, it really just depends on what constitutes. And so the easy answer is, well, if you want to drop myself a note or drop Paulo a note, we can, with the details on it, we can tell you whether or not it's a simple device. But you can also go to the -14 standard and it will define what a simple device is. And I can't remember exactly the parameters off the top of my head, but it's in -14 and it's also in 60079-25. That will give you the parameters. If it's basically in effect a non-energy storing device, if it doesn't have any capacitance, there's no, no battery, there's nothing like that. Anything that has a printed circuit board generally is not considered to be a simple device. So if it doesn't have a printed circuit board on the inside, it very well may be a simple device.
As Bob mentioned, if you want to send us a data sheet of the device, we will be able to tell you. Can a mixture of IS signal versus and with IS instrument and non-IS signal with EX instrument in same control panel? So basically the question, can we mix IS and non-IS in the same panel?
Yes, yes, you
Yes,
can. Yes,
provided.
you just, here's the key thing to remember. You have to keep a minimum of 50 mil separation between your IS and non-IS. And that 50 mil separation applies if we're running it in cable trays or inside of our panels. One thing on the outside of our panels, if one or more of the cables, your IS and maybe non-IS, are armored or sheathed, if you will, with an overall screen or shield, then that 50 mil separation doesn't apply.
Okay, there was a question if our product was certified for North America. They are, either UL, sometime FM, CSA, but always certified for North America. It's one of our main markets. Because we're running late, so that's why it's
Yeah, no worries.
Non-incentive versus IS. When can we justify one versus the other? Bob?
Yeah, the brief answer is non-incentive is a protection concept that we recognize in the US for Class 1 Division 2. It's not a protection concept that is recognized in the IEC standards. It's a very similar concept to energy limited NL, or now known as IC. So it's kind of the least form of intrinsic safety, if you will. Again, it's very, very similar in concept, but it's only recognized here in the United States for Division 2 applications, but it's not an EX protection concept that's recognized per the IEC standards. It is very, very similar though, for EXIC, if you will, level of protection.
Okay, great. I guess that's it. We have a lot of always the same questions. We're looking at different webinars. Can we do this? Can we do that? You can look up online our webinar schedule. And if there is any specific topic you guys want to see, just shoot us an email. We will look at it. Me and Bob are always looking for ideas on what webinar to prepare. So, and then you can review our webinar through the YouTube channel, JMI YouTube channel. Go on there, link to it, register for it, and you can always review all of the past webinars. Okay, let me launch the last poll so we can go, but I shut down the poll, so I don't know where I put them. Well, I really don't know where I put it. But let me stop sharing, and then you can, maybe I can find an easier way to open the poll here somewhere. Here we go. Launch. So basically, guys, how did myself and Bob do this webinar? Please give us your vote. And then I guess we have no more question live. So after the poll, we can say goodbye, and we will probably meet next year.
Yeah,
So to all of you, our best wishes for the upcoming holiday period, right, Bob?
Yeah, absolutely. Yeah, have a wonderful holiday.
Let's hope for some of this mayhem that's going on around the world, at least for this holiday period, comes to an end.
Yeah, let's pray for peace and prosperity and no more wars. That'd be lovely.
Be lovely. Okay, thank you guys. Let me show you your result. Thank you again. Thank you for your votes. We'll see you soon, Bob. We'll see you soon, guys.
Thank you so much. Bye-bye.
Thank you. Bye. Bye-bye.